Okay, so we're going to do lab sheet 3, as you can see here. Scan tool, generic scan tool data. I only have a generic scan tool. Unfortunately, I don't have access to the scan tools at the college, so we're going to use my personal one. It does a pretty good job. It's a pretty good tool. So that will get us through our sheet. So you can see the sheet here. The bottom portion has the little chart where you're going to put scan tool data in that you're going to see on the tool. The top has a few questions, some of which we spoke about during theory class earlier. Some of it you will get off the scan tool during this lab. First thing we're going to do is plug our scan tool into the data link connector. So we are going to come around here to the vehicle, and we're going to get inside the vehicle here. Now, most scan tools, and as we discussed this morning in theory, should have the data link connector located just under the dash here. Of course, it's not here. Now, one of the protocols for OBD2 was no hidden connectors. However, as we can see, they didn't follow all the protocol. There's our data link connector. It is behind this cover on the dash or on the instrument cluster. And actually it says right on it OBD. Okay, so the OBD plug on this is behind this cover here. So we're going to take our lead and we are going to plug it in. Just like that. So it just plugs in. Very, very simple. All right, and that is it. And then we need to turn our key to the run position to, of course, power up our PCM so we can have communication with it. All right, so I'm going to move around and come back to look at our scan tool. So hopefully we can see what we're looking at here, and we will focus in on our tool. Alright, so we can see our screen. So what we have here is a launch scan tool. It is called a Code Reader 7 Plus. Okay, it's not a bad tool. It is generic only, of course. It will give us data. It will give us graphing availability. So it does give us quite a bit of ability for a generic scan tool. All right, it will also allow us on this particular one to use to actually access the airbag and ABS systems as well. All right, so I'm going to start the vehicle. We're going to scroll through this and look at a few different things. The first few questions on our sheet we talked about in theory, so you can fill that out. All right, so we're already in mode here right away. Let me escape this. So we will, this is our first screen. As soon as we come in and turn this tool on, this is our first screen. Okay, so we'll just zoom in a little bit. Stay within focus. That's the big problem right now. Trying to read this in focus has been a bit of a chore to figure out. So this seems to be working. I'm just going to leave the tool where it is, and I'm going to manipulate the buttons on it, and you'll see the screen change. But that is really all that we're going to do here. Okay, perfect. All right, so this is my where I'm going to go. I'm going to go into diagnose. I'm going to push OK. Now, if I want to go into generic mode, I'm simply going to click on the little engine icon here. So you can see that red square around it. If I scroll over, of course, it is going to go around the different options on this menu. I do have the option of going into vehicle-specific mode, but it's still going to be generic information. So if I go to scan here and I push OK, it's going to allow me to choose the vehicle that I want to work on. So we are working on a 2008 Hyundai Accent. So I'm going to go into that. And then it is going to go into general area, so I'm going to push OK. We have an accent, OK. And we have a 2000, and OK. So this is only going to 2007. So I'm going to back out of here, and I'm just going to go to generic. Only because it's only a year difference, it may make a difference. So I'm just going to go to generic mode, and we're just going to use that. Okay, so we can see our mill is in the off, so I don't have any codes at the moment, turning my check engine light on, but I do have 3D diagnostic trouble codes. So, like we talked about this morning, it's going to turn on the light off if it passes its self-tests, but it's going to keep diagnostic trouble codes in memory for up to 40 key cycles, or 40 warm-up cycles. Okay, it's completed all the readiness tasks, as we can see here. Some are not completed. It shows how the data stream, how many different PIDs are supported, 33 in this case. Pretty good amount of information that we have available to us. So I'm going to push OK, and we're going to move on. So I am at my first mode, and that is read codes. Okay, so a couple of questions here. We'll scroll through all of them. Right, how many modes are available? So we have read codes and erase codes. All right, I don't want to erase them. Let's go in and see what we have. So we have two computers, and I know ECU2 is supported, not ECU1. So we're going to go into ECU2. And so we have our first code here, P0118. Engine coolant temperature circuit high. We have an injector circuit open code. And we have a misfire detected. Well, that makes sense. If I have an injector that's not working, I'm obviously going to have a misfire, so that makes sense. And our fourth code is an evap code. So we have a pending code for the evap system. Pending meaning that this is a 2-trip code. So this needs to fail a second time before it's going to become a hard code. Okay, so this is pending. It's failed its first self-test. If it fails again, then it's going to set a code. Okay, so this has to go through another drive cycle before it's going to do the self-test and possibly set this code. Okay, so that is all of our codes. Let's escape here. Escape. Alright, I'm not going to erase anything at the moment. Let's go to IM readiness. See what we've got here. Back to ECU. See, if I go to ECU1 here, I don't believe it's going to support it. Okay, so it didn't support ECU for an ECU1, right? NA. So there's nothing in ECU1. So I'm going to escape here. We're going to go to ECU2, and we're going to look at it. So since DTCs were cleared, and now it's showing us OK as opposed to NA, which is what we saw in the other ECU. Okay, so it's showing us all of these have passed. Ones that say NA, it doesn't run that test for this particular vehicle. Alright, so we'll scroll through all of them. Misfire monitors, okay. So whatever was the cause of that misfire on cylinder 3 appears to have corrected itself. So it looks like my camera's having a little bit of an issue focusing on this. We'll just give it a second to settle down here. Alright, that's the problem with using screens and cameras. Sometimes the focus can be a bit of an issue, but we can make all of that out. Alright, so that is all of our screens for our IM readiness. Alright, so we've scrolled through it. There is 10 screens in total. Okay, so let's escape that. right out of here, we'll go to our main screen. So we have freeze frame data available to us. Of course, it's an OBD2 protocol. So what I'm going to do is scroll down to that, and let's see if we have freeze frame data related to any of the codes that we have in this vehicle. So we're going to connect on that, back to ECU2. Alright, so freeze frame data, as we can see, is for P0303 up in the top right corner there. So this is a type A code. Of course, this has priority over our other codes, right? A misfire always has first priority, as we discussed in theory earlier today. So we can see P0303, we have freeze frame data for that. And if we scroll through the freeze frame data, it's going to give us some information based on when this code's set. Okay, so intake pressure. So we're at 12.9 inches of mercury when this set. Fuel trim values, the vehicle wasn't moving, but engine RPM was at 1195 RPM. We can see there. Scroll through again. Timing advanced, we were at 20 degrees advanced. Absolute throttle position was 6.3% open. Okay, so the vehicle was running for 9 seconds when it happened. Okay, fuel level, so we have a full tank. Absolute load, we were at 29.4%. Throttle position, okay, so ambient air, that is all of our data for this code. So you can see we have a fair bit of information based on when this code's set that will help us during our diagnosis, possibly. Freeze frame data doesn't always help, but it does help occasionally, and it's good to have it. It's a good idea to never erase codes until you've repaired the problem, in case you need to refer back to the freeze frame data. Because once the freeze frame data is gone, you won't get it back. So just leave the codes and freeze frame data in the PCM until you've made your repair. Alright, so I'm going to escape this. Alright, let's go see what else we have here. O2 sensor test. The vehicle needs to be running for that. Onboard monitoring. Okay, so that is going to show us our self-test. This would be mode 6 that we talked about earlier. Keep going. EVAP system test. Now I don't think that it is supported. We can check on this, see what it says. I haven't used it on this vehicle for this. Yeah, EVAP system leak test failed. Alright, I wasn't aware it even ran it, but anyway. Let's escape that and let's go to vehicle information. See what they've got for one, not supported. Okay, calibration identification, however, is information that could be valuable to you. If this PCM needed an update, we have the calibration information and we could compare it with the most current information, and that's going to give us an idea whether this PCM is up to date or not. Okay, let's escape this and go look at ECU2. Okay, and there's our calibration identification for this vehicle. So ECU1 really isn't supported. ECU2 is where all of our information is on this particular vehicle. Okay, so we can see our VIN, right? There's the VIN for the vehicle right at the top. Calibration identification number below, and verification numbers below that. So all of the information you would need if you went on Hyundai's website and looked at whether or not this vehicle needs an update for whatever the problem happens to be, this is where you're going to find the information. Alright, so we're going to escape that, get right out of here, and we're going to go right back to our main menu. Okay. Oh, alright, so we went a little further than we wanted to, but that's fine. Give it a second to download this again. Alright, so, okay. Alright, so we're going to go now to data stream. All right, so I'm going to go into data stream, and I'm going to go start the vehicle, and we can look at our data stream with this vehicle running, and that is for your little chart at the bottom of your lab sheet. So we're going to push OK. We're going to view all items, and while that's loading, I'm going to go start the vehicle. Okay, so there we go. We have the vehicle running, and we can see fuel system status. So we're in closed loop. That was very quick. Now, I had this vehicle running a little bit earlier, so it was still fairly warm. That's why I went into closed loop so quickly. Calculated load at idle, we're at 28.6%. We can see our coolant temperature, 134 degrees Fahrenheit. Our fuel trim, so we are slightly adding fuel right now, but you can see it toggling back and forth. That is normal operation. We'll scroll to our next screen. We can look at our long term as well. Our intake manifold pressure, so this is a speed density system on this vehicle. We have a map sensor, and we can look at, and we can see we have 11.4 inches of mercury on our map. All right, so on your little chart on your lab sheet, of course, not everything is going to be supported. Back at the college, we have a choice between various vehicles with different components on the engines. Okay, we're just doing the one for this video that you're going to use on your sheet. So in this case, if you come across a question and it's not supported, just put NA. That's fine. That's all you need to do. Okay, so we're going to scroll through. Vehicle speed, of course, we're not moving. The vehicle stationary, we can see engine RPM at idle. We're at 865 RPM. Ignition timing advanced, so we're around between 0 and 6 degrees advanced. Number one cylinder. Okay, intake air temperature, 95 degrees Fahrenheit. Absolute throttle position, 5.9%. O2 output voltage, so this is our upstream oxygen sensor, bank 1 sensor 1, and we can see that it is toggling back and forth. This is a narrowband oxygen sensor at the front of this vehicle. We can also see our short-term fuel trim below that, and we can see the two change back and forth, right? So they're a direct mirror image of each other. When the oxygen sensor goes low, the fuel trim's going to go higher, and vice versa. Okay, so just watch that for a second. See how the two toggle back and forth. I'll actually put this in graphing mode briefly, and you can see the two of them once we've scrolled through all this data. Okay, so our downstream oxygen sensor, bank 1 sensor 2, is a nice steady 455 millivolts, which is exactly what we're looking for. That means that the catalytic converter is storing oxygen as it should, and it's not escaping. Therefore, we see a nice steady output from our downstream sensor. It's exactly what we want to see. Okay, so that is awesome. Short-term fuel trim. Okay, so this, I believe, is going to be lambda. One lambda is going to be 14.7 to 1. It's showing us in 99.2%, which is almost 1 lambda. Okay, it's actually slightly below, so it's actually running tiny bit rich, but not enough to really worry about. OBD2, we can see right on here, time since engine start, so I've had it running for 224 seconds now, and it's counting. All right, moving on, scrolling through, fuel level, full tank. So it shows number of warm-ups since diagnostic trouble codes cleared, distance traveled, quite a bit of information here. Evap pressure, so this is looking at the pressure sensor on our fuel tank. The baro sensor, most likely on this vehicle, is built into the map sensor. Catalyst temperature, so we can see our converters at 675 Fahrenheit, and it's working properly, and we know it's working properly based on the activity from our downstream oxygen sensor. Control module voltage, so we can see our source voltage Charging system voltage, obviously, we're at 13.8 or 13.9 volts. Absolute load, 22.4% at idle. Fuel air commanded equivalence ratio, right? So we are at basically 1 lambda. And of course our ambient air temperature, 73 degrees Fahrenheit. Okay, so that is all of our data available to us. All right, so quite a bit of information here that we have available with this vehicle. Coolant temperature, 179 Fahrenheit. So we can see we're almost at operating temperature. This thermostat should open at around 195. So we're almost there in closed loop. All right, so I'm going to escape this and we're going to go to graphing. And actually I'm going to select a couple of items first. So I'm going to select, scroll down here, the oxygen sensor. So we're going to go short-term fuel trim bank 1. We're going to select that. And let's go down and find oxygen sensor output voltage bank 1. All right. And now we're going to push escape. That will confirm everything, and we should see them both up on the screen. All right, so we have our two here. I'm going to go to graphing mode. All right, I gotta choose it again. Okay, that's fine. We'll do that again. Short-term fuel trim bank 1. We'll check that one. We'll go back into oxygen sensor bank 1. Okay. Escape. There we go. All right, so we can see in red and black. Whoops. Bumped into my thing here. Okay, give her a second. All right, so we can see in black our oxygen sensor. Beautiful oxygen sensor pattern. But we can also see in red the response from the PCM to that oxygen. Okay, so the PCM is actually causing this. The oxygen sensor doesn't switch like this under normal operation. The oxygen sensor is showing us rich and lean. Rich is at the top of the screen, lean is at the bottom, and it's doing this by the PCM adding and subtracting fuel. And we can see the PCM doing that with our red trace here. So the PCM is adding and subtracting, and it's causing our oxygen sensor to go from rich to lean, as we can see. So when we're at the top of the scale here, we're rich. We're at the bottom of the scale, we're lean. Okay, now I prefer to call this, instead of rich and lean, an abundance of oxygen at the bottom and a lack of oxygen at the top. That's really what we're seeing here, not so much rich and lean. A lot of people get confused thinking the oxygen sensor is reading fuel. It's not. Oxygen sensor doesn't know what fuel is. The only thing it can read is, of course, oxygen, and that's what we're seeing here. Okay, so I believe that we've looked at everything you need to fill out your lab sheet. So that will be the end of this video. I'm going to end it now, and we will move on to another lab sheet after. So fill out your sheet, use the information we see on the scan tool. I realize it's not the greatest focus, however, it is readable. I can see it in the monitor here, and I'm sure you'll be able to see it when you look at the video. So fill out your sheet. Like I said, if something's on your sheet that you don't see in the video, put NA, but just be aware that if I find it, I will take a mark away if you didn't find it. So make sure you look thoroughly through and watch this video from beginning to end. Stop it, rewind it, play it back a few times as you're filling out your sheet so you get all the information you need. Alright, that's it for this video. I will talk to you later.